Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a high school physics competition problem that looks tricky at first glance. So, we have a slope here. The slope has an angle theta with the horizontal direction. So then we have a ball and we release above the slope, and as we can expect, the ball will go down and then bounce back into the space, and then at some moment it will begin to drop again and then bounce up again. So we want to know time between each collision, whether it decreases, remain the same, or increases. And we also want to know the distance between each collision, whether it decreases or is the same or increases. This problem looks very difficult because how can we calculate something like bouncing down a slope? But don't worry, let's set up the coordinate first. So again, this is the slope, and then so instead of setting up x along this direction and y along that direction, we set up x and y coordinate on the slope. So the direction that is parallel to the slope we assume as x, and then the direction that perpendicular to the slope we assume to be y. And so as we can see here, the ball is subjected to a gravity force that is mg. Now the gravity force along the x direction will be mg sine theta, and then the gravity force along the y direction is mg cosine theta. So in order to have a better view, so we redraw the coordinate, but this time along the horizontal direction, just to have a better view. So here is the slope, okay? And then here is x direction, and then here's y direction, and then this is the small ball with the mass, and then as we already know, along the x direction, the ball has a force mg sine theta, and then along the y direction, the ball has another force, which is mg cosine theta. Now we look at the force along the y direction. Okay, you will drag the ball down, and when it hit the slope, you will bounce up. Because everything is ideal and is elastic here, so the ball will go back to the same height, and then it will go down like that again, then it will go up again like that. So as we can see in this situation, the time between each collision will be the same. So because it go down and go up in the same manner. But along the x direction, it is slightly different. On x direction, it has a constant force acting on this ball, which is mg sine theta. So it will accelerate the ball along x direction. So along x direction, the ball move faster and faster. So if we plot the trajectory of the ball during the bouncing, it looks like that. It looks like that. Y direction, it will reach the same height, but then the x direction, it will become the distance between each collision will become larger and larger. So you become like that. So it will become even larger that way. So the answer is that time between each collision, we talk about y direction, it will be the same. So this is the answer. And then the distance between each collision, we're talking about x direction, it will become larger and larger because there's a constant force acting on the ball. So it will, the answer is increase. So thank you for viewing. If you like my video, please comment, like, and subscribe. Thank you.